Hi, good afternoon, and welcome to Insight60. My name is Stephen Shield, and I'm the External Relations Director here at the OGTC. I'll be your host for today. So we're very delighted to have around about 160, 70 people join us today on the webinar. It's fantastic turnout. Thank you for taking the time to spend with us this afternoon. So what is Insight60? Well, it's 60 minutes of hopefully very insightful and interactive session with us today, focusing on issues surrounding the energy transition. That's what we're trying to do with this series, is explore the energy transition in some detail. So we have invited leaders and industry experts to the series, and they've been telling us all about the challenges and the many solutions that are emerging to help guide us through this complex energy transition. The format's very simple. There's 30 minutes of insights from our keynote speaker today. Then you'll hear from our panel, and we have a great panel today. We've got Karen Turner, Professor and Director of the Centre for Energy Policy at the University of Strathclyde. We have Myrtle Dawes, who's the Solution Centre Director at OGTC, and our very own Vinny Mugandath, who's Chief Technologist here at OGTC. So once our speaker has done his thing, then the forum is yours for 20 minutes to steer the conversation, really get the discussion going and ask questions directly of our guest speaker today and also the panel. So remember, this session is designed to be interactive. Please use the opportunity. Come forward with your questions for Sir Jim McDonald, our speaker for today. So before we carry on, let me just point out a few housekeeping issues. You can all read that slide, I'm sure, so I'm just going to highlight a few things. All attendees today are automatically muted and your camera will not be turned on. Please use the chat function to type in your questions, and I would encourage you to submit your questions throughout the presentation, ready for the 20-minute Q&A round. I will ask if you're happy to actually ask your question personally. If not, I will ask it for you. And lastly, we are recording the session today. So if anyone has any issues with this being recorded, then please feel free to drop out. But we record these sessions and post them onto the OGTC website for everyone to enjoy later on. So I don't think that our speaker today will need a lot of introduction, but let me try. We have very delighted to have Professor Sir Jim McDonald with us today. Jim is the Vice-Chancellor of the University of Strathclyde. In my opinion, the finest university in the UK, if not Europe, having graduated from that particular institution. He's an esteemed engineer. I mean, he's president of the Royal Academy of Engineering, and you know, he's one of the best sort of academic and engineers that Scotland's produced in a long time. He co-chairs the Scottish Government's Energy Advisory Board with the First Minister, and he's chairman of the independent Glasgow Economic Leadership Board, as well as holding positions in private industry on boards and with the Offshore Renewable Energy Catapult and the UK National Physical Laboratory. So bags of experience, and I'm sure bags of insight. Jim, welcome to Insight60. We're really looking forward to hearing from you. And if you don't mind, I'm just going to hand the stage over to you now and let you get on with the presentation. Your 30 minutes starts right away. Thank you.
Great. Well, thank you very much, Stephen. And it's a pleasure to join you and colleagues here at the Insight60 session. And thanks for those that have participated by joining the meeting. So I'm going to take you through a fairly whirlwind overview of the net zero challenges and opportunities. But it's always best to tell you where I'm going to land. And where I'm going to land is to extol the requirement for a systems approach to delivering, the objectives and the necessity for achieving a net zero infrastructure, net zero way of working and living. So Hannah, thank you very much, is going to support me on this one. So very obvious statements, but fundamentally we should always reflect on the fact that nature is not unlimited and its abuse and exploitation comes at a price. And you can see from this graphic exactly what we're talking about. Nature is under threat, and we have a responsibility morally as well as our ability to maintain an economy and keep a healthy situation for our citizens. Thanks, Hannah. We've seen that nature is sending us signals, and there are many. We're living them and experiencing them more and more often. Perhaps some of the more dramatic ones includes the Californian fires that we could see, you know, unbelievable seeing in a developed nation how they can be, in some parts of their country, brought to their knees in terms of the exposure to the ravages of nature. And thanks, Hannah, with that, when we had forests denuded of the trees and the damage that was caused, the destabilization of the subsoils and the rains that came after it, we saw these Californian mudslides. So a real issue there about exposure and risk and the need for resilient infrastructure. Thanks, Hannah. Of course, I reflect on my own way of living as a citizen, and I cannot preach because I've got to make sure that as I travel, as I consume, I have to take my own personal responsibilities as well as talking through my institutional roles. But we do continue to increase emissions. You can see, you know, the numbers that have been going up steadily year on year. You know, the gigatons of CO2 on the x-axis. However, as we understand why over the past year, we're still to get a final audit, but possibly maybe a 7% drop off in CO2 emissions. But the question is, well, what have we learned there? There was clearly a major impact on business and industry and transport. But can we now pick up the lessons of, as the economists would tell us, we're starting to see that perhaps we can begin to decouple productivity from carbon emissions. But nonetheless, we have got decades to go and we have to act responsibly. Thank you, Hannah. So we'll just flick through a couple of slides and we can see some of the context here. Just keep pressing, Hannah, please. So we've got Greta Thunberg, an inspirational young woman, massive impact. We've seen the Extinction Rebellion movement ignite an interest in society. But of course, we need to inform all of this debate with good evidence, good challenge for government, but of course, as an engineer, also to come out in terms of pathways to get to 2050 in a sustainable way, but in a way that can drive economy. And the Royal Society of Edinburgh published a really good report on energy futures about 18 months or so ago. I would commend that to you. And the Committee on Climate Change, the chief executive there will be known to many of you, Chris Stark, whom I worked with very closely when we was in Scottish Government, the CCC bringing forward the challenge of net zero to 2050, and we have now a platform that's only about 7 months away now, and that's COP26, where we hopefully, as we go forward, as well as talking about Tokyo and talking about Kyoto and talking about Paris, that hopefully in the decades to come, folk talk about Glasgow and Scotland as the place where acceleration really came from. Thank you, Hannah. One slide I often refer to because it encapsulates technology, policy, and the way that people live. There's what we broadly refer to as the energy trilemma. You know, the competing activities, the tensions that we see between the black line there, the correct drive towards decarbonisation. But whilst we do that, the blue line, it has to be affordable. We have to do this in an economic way. And the green line, it's about reliability. So those three are typically the three elements of the trilemma, but of course it's even more multiply dimensioned, and that is public acceptability and consumer opinion and behaviours. If we come up with technologies or systems that are not used or they're unacceptable, then we're not likely to get the acceleration of that decarbonisation that we need. And the last one is, how do we capture the economic benefit of this? Now, we'll come back later on to the overall argument about putting a realistic cost of carbon into the equation, so that when governments make the assessment, when industry make their investments, when public engage with it, it's with a full understanding of the cost. But I'm glad to say now a good friend of mine, Lord Nick Stern, I was involved in a consultation with him when he set up the Stern report coming up for 15 years ago. Nick proposed, as an economist, he's a professor at LSE, that the economics of climate change, we can build industries and economic opportunity whilst we're doing the right thing. And that's what I would say. And I won't just say particularly about Scotland, but certainly Scotland, as we've shown thought leadership, as we've shown that we punch above our weight as a small nation, we do want to build economic value as well. And OGTC, for example, is a very important part of that, as we have them as not only a catalyst, but a driver for the energy transition. Thanks, Hannah. And a busy slide, but let's take the headlines, and many of you will have seen these, but I would commend to all of you, please have a look at these things. Just in the past few months, we saw Mr. Johnson, the Prime Minister, come forward at the end of November with his 10-point plan. Very exciting, very aspirational, and that's right and proper. But that more or less gave us the framework for what the next decade and beyond might look like. Committing to an offshore wind capacity of up to 40 gigawatts over the next decade. That is a big ticket target. That's about an order of magnitude up on where we are just now. Great opportunities for Scotland there as well, not just for siting, which is important, but how do we capture the economic benefit in terms of major projects? Hydrogen getting played in very heavily these days. Nuclear, and I'll touch on that briefly in a moment, but advanced modular reactors and small modular reactors, there is an economic opportunity for the UK there, through to electric vehicles and all the way to jet zero and greening the marine industry, and right the way through to how we build and support the natural environment. And then the Prime Minister's Council for Science and Technology, I have the privilege of sitting on that. My capacity as President of the Royal Academy of Engineering. Just about a year ago, CST, as it's called, submitted, we don't produce reports, we send letters to the Prime Minister, but they tend to be 20 to 30 page letters. So to all intents and purposes, they are reports. Our proposal was we have to take a whole systems approach to achieving net zero. Of course, technological underpinning is critical, but we need strengthened institutions and absolutely coherent and consistent leadership from government. We need to do the modelling, we need to get data and evidence, and we have to also mobilise finance and international contributions. And the last one, and there are many others I could have included, but I would commend the Energy Systems Catapult report to you of about 9-10 months or so ago, when they did the modelling on the back of the CCC work to look at what kind of infrastructures we would need to create to achieve that 2050 target of net zero. And if we are going to go for wholesale electrification, there are consequences. Depending on some scenarios, that could be 2 to 3 times the electrical generation capacity that we currently have. And we currently have an installed capacity in the UK alone of about 65 to 70 gigawatts. So we're going up prospectively to 200 gigawatts of electrical power to get the work around hydrolysis or electrical power generation or the electrification of transport. Nuclear and bioenergy and carbon capture and storage features very strongly. Renewable is a major opportunity, but another way for us reimagine what the grid looks like. We can go back to decentralized systems that we started the 20th century with, but we can now have a much more reactive and smart grid in effect, and all the way through to negative emissions with direct air capture of CO2. And you can see again, transport electrification, industry electrification and behaviours. So I commend these reports to you. Thanks, carry on please. Thanks, Hannah. And I should admit I'm an electrical engineer, so systems come naturally to me in terms of how I see things connected. But the traditional power system, for example, you see up in the left-hand corner, large centralised generation, all the way through the step-up transmission down to major load centres, typically commercial, industrial, and then all the way through the distribution network. But of course, if we go to the next slide, in this rather cartoonish approach, but it captures the essence of it, we're seeing effectively an inversion of how the grid has evolved over the past 100 years, where it's large centralised stations through high voltage grid up to, in the UK, 400 kV, and some other parts of the world up to 1 million volts DC, big transmission infrastructure which you need for bulk energy transfer. But increasingly, I think we'll see the focus on distribution networks as the demand evolves, as electrification for cars and heat and cooling comes, and as we get the sources distributed as well. Thank you very much, Hannah. So again, another busy slide, but let me give you an idea of the scalar here. And this is the growth in controllable sources. So just take the left-hand bullet points. First of all, there is an increasing and massive growth in monitoring and control data. More sensing, more data acquisition, because systems are becoming more complex, and even more controllable elements that we have to look at. A big, 2 or 3 orders of magnitude prospectively of generation sources, from the big 2 gigawatt energy hubs to the few tens of kilowatts that we might have in and around our homes. Energy storage is going to be key. ICT, or the data capture, data analytics, intelligence is absolutely key. And this whole idea about sustainability and the smartness of our systems is key. And if you look at the graphic on the right, you can see just now Generation providing control, that's how National Grid, Scottish Power and SSE are trying to manage stability in the system. It's up to about 15 very large generating units looking after frequency control. But in another 10 years' time, there could be over 500,000 generation units, that some of them controllable, hopefully most of them observable because of sensing. But the challenge on the utilities, the challenge on the system operators becomes significant. And as we can see here in the middle rank, distribution network automation, 10,000 devices going up to almost 1 million. And automatic control homes. Just now, I mean, we've got it to some extent, but if we really get this wholesale move towards energy management, demand side participation, we're going up to 15 million devices. So that's just to give you a scalar of this is the opportunity we must pursue, but here's some of the technical challenges we get after it. Thanks, Hannah. So let me take a few slides just to give you some of my thinking on systems approaches. As you heard from Stephen, I'm president of the Royal Academy of Engineering. We've been doing work for about 7 or 8 years on systems engineering per se, and how it impacts on health systems, transport systems, aerospace. But we're now taking the systems approach, and through our National Engineering Policy Centre, proposed, and it was the Royal Academy that supported the CST letter to the Prime Minister about taking that whole systems approach. Thanks, Hannah. And what do I mean by that? Well, I assume, Stephen, that we'll circulate these slides after the talk, so I'll simply commend some of these reports to you from the Academy, and it's about building awareness of the values of systems. Very often we get this rather false debate between, well, is it wind, is it marine, you know, is it bioenergy, where does nuclear play, how do we decarbonise gas? The truth of the matter, it's all of these things together within an integrated system, and then to deliver that, we need to get that systems perspective by connecting government. So that's the other challenge here. It's not just about technology and envisioning energy systems of the future. If government don't work in the cliched joined up way, this will not happen. You know, whether it's the Treasury, whether it's the Cabinet Office itself, the Department for Housing, Communities and Local Government, BASE or DCMS for communications and control, and then you layer in local government, cities leadership and local authorities. We need that whole systems approach which connects and then of course adds to that the society within which we live and the citizens that engage with this. Thanks, Hannah. So I would like you to compare very favourably this idea of systems thinking with what the Scottish Government's been doing for the past 6 or 7 years, and that's coming up with this proposition that our energy strategy and our climate change plan has to look at our impacts on cities and communities, which means that the Scottish Government have been thinking about systems for quite a few years. And again, a lot of credit to Chris Stark on that in the Scottish Energy Advisory Board. Thanks, Hannah. Here it is in essence. This is very much a condensed version. So the draft energy strategy from a few years ago proposed, before we started to hear this reflected in the Westminster pronouncements, that we take that whole systems view based on economic modelling and informing a view of our future electricity supply and demand, but looking at that integration with transport, heat and power, and driving towards a much bigger percentage of our all energy renewables target by 2030. And the 2045 transition is commendable. There are very sensible reasons why Scotland might be able to do this quicker than 2050. And I think by focusing in on this, with our climate change plan, using our resources, using our the architecture, metaphorically and physically, to achieve this is great. And my own city of Glasgow, which is hosting COP26, committing to a 2030 net zero plan. It's that leadership, that commitment and understanding systematically how that might be achieved. And last but not least, that smarter model of local area provision. Back to what I was saying in that cartoon I showed you earlier, building on the strength of that big monolithic grid system and looking to decompose and interconnect into smaller distributed modes is entirely technically feasible. Thanks, Hannah. So back to the Royal Academy of Engineering proposal here, and that's themed to supporting government in getting to operationalise system approaches to net zero. Now, that's a mouthful, but it's basically saying, well, where do we start? We've got 30 years to 2050, but we need to start what we call the low regret options. We need to start in that systematic and that systems approach to say, what investments do we need to make now that by and large unlock pathways to that net zero target? So, I mean, there's always very great temptations to invest in specific technologies or projects, and that is fine, but we should only be investing in the major projects if they are giving us the building blocks and the stepping stones towards that envisioned low carbon future. So thinking ahead, so what do we need to do now, what we need to do next in order to get to that future? So that systems approach is key. Thanks, Hannah. And when you get these slides, you'll go into a wee bit more detail, but I wanted to give you an example. We have a fantastic group that's working in the National Engineering Policy Centre, led by a woman called Dervilla Mitchell from ARUPS, where it's got ex-Chief Executive of National Grid in there, people from the oil and gas industry, people from consumers activity. And we took decarbonising homes as a massive example and a big challenge. It was going to cost us trillions of pounds to decarbonise homes over the next 20 years. So where do we start? And this diagram gives you an idea of where the interdependencies are. And that's where systems thinking comes from. Understanding where the key components are technologically, policy-wise, behaviourally, and economically, and then seeing where the dependencies are in order to achieve for example, decarbonised materials. You need to think about the construction industry. You need to think about the supply chain and manufacturing. And then you need to think about, well, if the construction regulations are not aligned with what we're trying to achieve, we'll not get to that ideal outcome. So this is just to give you an example. You can see this report. I would suggest you have a look at this net zero systems perspective on climate change. So this is a systems diagram, which allows you to see where the hotspots, as it were, and perhaps pathways to what the low regret initial investments can be to achieve that net zero architecture. Thanks, Hannah. Next up. And again, I won't rest too much in this one, but for the construction industry, staying in this same theme, it's about new approaches to design and specification, the business of construction and the manufacturing is off-site, and then you've got the transport piece as well. So if you are building construction off-site, you need to transport the materials and the components, and thinking about reuse. So that circular economy piece gets played in here in terms of materials, smart design, and then ultimately the energy efficiency of the building. Thank you, Hannah. And again, I'm going to move through this because we've only got another 10 minutes here. But hydrogen is now really coming through thick and fast about how we might do this. And the oil and gas industry, for example, has a significant role here. Whether it's generating new fuels like hydrogen or ammonia, whether it's in the whole CCUS piece. But we're now, you can see another report here, the Royal Academy submitted a significant piece of independent evidence to the House of Commons Science and Technology Committee just about 6-7 weeks ago, trying to give that systems perspective. Again, sorry about the illegibility about the diagram, but I'm hinting for you at the complexity approach that one must take is to get the details of the complex system and then the decomposition of where we can then focus, understanding the interdependencies and where the priorities might be for investment. So that systems map has been critical. It's enlightened the policymakers, and we should show them respect. They have a very tough role to take on. But the key thing that's also coming through is that critical dependency on industry engagement and all of this, whether it's technological innovation, whether it's investment in projects, or whether it's the business models that allow them to drive economic value. And fundamental to this is the research and innovation, of course, which flows from our universities too. Thanks, Hannah. And I'll head for the finishing line here in the last few slides. Hydrogen in Scotland today, some great lessons being learned. This is a slide from the SHFCA, and we can see what's going on in Orkneys with we've got a hydrolyzing, I beg your pardon, electrolyzing plant to generate hydrogen, power being produced by renewable sources, hydrogen storage, and then transportation into Kirkwall, and then using that fuel for vehicles. So again, there's a microcosm of a system, a lot of interdependencies, but through all of that, the objective function, as it were, here is to minimise carbon production and maximise the impact of net zero technologies and their use for societal benefit. Thanks, Hannah. And something that our colleagues certainly in and around Aberdeen will be very well aware of, and this is the scaling up with the green and blue hydrogen, whether it's, as we see in the case of Orkney, that green hydrogen, as it were, with the source power coming from renewables, or blue hydrogen where we go through some kind of reforming processed from hydrocarbons that are brought ashore from the oil fields. But some great opportunities to base great thinking, great technological and business capability through Pale Blue Dot and the Acorn Plus project, but just great. And we should make sure that once we do this, we scale it. Again, I won't drop down a rabbit hole, but late stage, large investments in late stage demonstration is critical. If we don't do that, the UK disease here is we do all the innovation and the great thinking, but we don't capture the economic value. So it's another message to UK government, indeed Scottish government. Late stage development at scale with large investment is the way to commercialise and then capture economic benefit. And this may well be a project of that ilk. Thanks, Hannah. And cities, let's not rule them out. I had this conversation just earlier in the week with colleagues in the Cabinet Office, as well as local government, devolved government is key. Cities are becoming increasingly important. Manchester, for example, is a monster-sized city. Edinburgh and Glasgow and Aberdeen aren't exactly small, but we need to think about how cities where much of our population live around engage in that net zero journey, whether it's infrastructure, whether it's transport, whether it's building design, whether it's consumption patterns. It's very important that we recognise that cities generate 80% of the world's greenhouse gases. So we've got a chance to win big there if we can get the power of cities behind this journey. Thank you. And I simply mentioned Sustainable Glasgow. I was involved in setting that up 10 years ago. It waxed and waned, but with COP26 coming now, Sustainable Glasgow has now become one of the principal vehicles where Glasgow is making that commitment to 2030, and that is, ranges from transport to infrastructure to consumption patterns. Thanks, Hannah. But we must decarbonise energy. Coming out of the Paris Accord, this is the sustainable development scenario from the International Energy Agency. You can see that top line was the emissions under the Paris pledges. And then from the Intergovernmental Panel on Climate Change, that 2-degree scenario at the bottom end, you can see over the next 40 years or so where we need to get to in certain models. Let's not forget, it's not just supply side, it's not just about sources, it's not just about generation stations and grid infrastructure. It's about how we use energy. So we need to improve energy efficiency by almost 40%. Get low carbon technologies up to almost 50%, and CCS, that storage piece is key. Thanks, Hannah. But how much power demand in a net zero emissions world? I mean, I gave you an example. According to that Energy Systems Catapult report, we might need 2 or 3 times the amount of electricity if we're going to go on this journey. So if we go to the next slide, here's a couple of curves. Hope you can just pick that out. It goes from 1990 to 2012. And there's been a plus 3% year-on-year growth on demand at the baseline. That 100% there, I beg your pardon, on the y-axis, it's percentage growth. On the x-axis, it's time. So it's about a 3% growth and about 1.4% growth in GDP per capita. But if you look at 2019, the world is consuming electric power at 23,000 terawatt hours levels. Now, that will have tailed off last year. Of that, there's no doubt. I've not seen any audited measures yet, but that will be down quite significantly, I would imagine. But then we've got to ask ourselves the question, are we going to kick back on to that curve? And if so, are we doing it in a way that's sustainable and feeds this drive towards electrification and decarbonisation? Thanks, Hannah. But of course, less demand is important, as I was saying, whether it's more efficient transport and much better transport infrastructure for public use, which has an impact on, back to behaviours, private car use, or if it's going to be new models, new business models, better efficiency in housing and industry itself. Again, we mustn't forget the whole drive to industry. Industry is a big player here. Drive on, Hannah, please. Or more demand, and as I was saying to you, see if the Energy Systems Catapult, electrification of transport, electrification of heating, cooling, that means demand, demand, demand. Now, that might be good as long as we see it from that systems perspective, in that we drive this through decarbonised energy production and more efficient use of energy. Thank you. And lots of technologies there. Now, in other talks, I might drop into the specifics of some of these, but it's just more or less an array here of, we can see that wind, solar, hydro, geothermal, nuclear as well. Of course, biomass, and ocean and tidal as we move out of coal and we minimise the burning of hydrocarbons over the next couple of decades. Thanks, Hannah. But nuclear is going to play a significant role. Nuclear power capacity worldwide is increasing steadily. And the Swedish Academy of Sciences about 7 or 8 years ago said, look at the next generation of fission reactors as a bridge by about 2050 to 60 into the first generation of commercial fusion reactors. So there's also always a question to be asked about storage of nuclear waste and safe operations and the likes. But we are seeing that nuclear has been seen as part of a low carbon future. But if we look at whole carbon life cycle accounting in terms of materials and production, there's a bigger equation to be had there. Thanks, Hannah. Wind pressing on apace. This is from the Offshore Renewable Energy Catapult. 12 megawatt turbines and now concept designs of 15 to 17 megawatt offshore wind, floating wind coming in now with Scotland with a real opportunity to capture that as a market and drive that 40 gigawatt offshore target for the UK and then take advantage of an export market. Thanks, Hannah. And over the past 15 years or so, what you've seen is this move towards renewables being the major component of added capacity. And this is, I think, an encouraging slide, albeit hard to see all the detail. Just look at the colours. In 2006, the added capacity for renewables, there was about 24 gigawatts. In 2019, it was 180 plus gigawatts. So you can see the migration of the change in the generation mix. Thanks, Hannah. We're into the last couple of minutes. But of course, we need to think about challenges, intermittency and variability. So if we go into the next slide, which implies storage is a big deal. Pump storage still represents over 90% of installed capacities. But if I break out that little slice there, which talks about non-hydro storage and electrochemical, that will grow, whether it's sodium lead batteries, sodium batteries, lead, flow batteries, supercapacitors, and others, like compressed air, energy storage and the likes. But storage is part of the game changer. Carry on, please. And I just wanted to put this slide because this is a vision of the future from an entity called the Global Energy Interconnection Development Corporation Organization. I do some work with them. They were stimulated by the State Grid Corporation of China, but they've set up a big organization. And the little chart you see here is it's a proposition of a globally connected world using super transmission levels, megavolt DC. And I just put a little reference at the bottom there. I had the privilege of meeting a man called Richard Smalley not long before he passed away, sadly, but Richard was a Nobel laureate at Rice University. And some of you might remember the invention of the discovery of buckyballs, which was the C60 atom, which would basically look like a football, highly structured, highly stable, but its proper name is Buckminster fullerene, but a real proposition for very small, highly conductive electrical cables, which could be used to connect over very long transmission distances. So again, Richard had this vision, even as a scientist rather than engineer, of an electrically connected world. So we need to continue to think big. That's a long way away if we're going to get there at all, but that big systems approach is maybe going to get us to a more innovative solution. Thanks, Hannah. Carbon capture, utilization, storage, a big deal, and I won't say too much about this other than that there are other experts in the room with us digitally. This a big part for the oil and gas industry to play here, where CO2 can also be used as a product, but also we decarbonize and drive towards that net zero future while producing electricity. Thanks, Anna. Oil and gas, as I say, a big part to play in that. Oil and gas understands big projects, investing and delivering projects, but also that commitment to the energy transition and decarbonisation, I think has been a sea change over the past few years. And I think the oil and gas industry are going to be a critical part of the future in delivering that vision. Thanks, Hannah. Another couple of minutes and I'll be done, Stephen. So we also have to keep on challenging through evidence. There will be winners and losers if we're not careful. So hopefully the I don't believe in global warming community is shrinking, because I think the evidence is irrefutable. Next slide. True costs have to be understood, a proper price of carbon so that the economic impact can be played in as we're trading off current infrastructure to new infrastructure and understanding the impact and costs on the planet whilst we build infrastructure and create economic opportunity. Thank you, Hannah. But you hear a lot these days about ESG, and this is not, I think, this is not greenwashing any longer. This is about environment, societal impacts and governance, and we have to understand a word that many corporates talk about is that's the purpose of our companies and institutions. And go to the next slide, because unless we get this right, there is no stable business in a chaotic world. And I think the fulsome engagement of business and industry in this journey is going to be critical, alongside the policymakers and government investment, and indeed the innovators and the talented people that are out there in business. And we're just to the final slide or two. Thanks, Hannah. And business is essential to the solution, and indeed can change as they're committing to and show leadership. And let me conclude. Go on, Hannah. Keep on going, please. Well, just in one last slide, and that will be us done. So conclusions. And we should do what Scots are also famous for, and that's drive forward into this net zero future with purpose and entrepreneurship. And we saw that at the end of the 19th century, beginning of the 20th century with Edison, Westinghouse, Lord Weir, who was the author of the 1926 Electricity Act, which produced the grid, and Page, who was the first CEO of the Central Electricity Generating Board. Well, absolutely in the midst of that exciting defining period for the development of energy systems. COP26, if it does galvanise action, and we can't guarantee that, will put our country on the map as the place that catalysed that next step to delivery. And it's a great and exciting place to be, and hopefully we can attract as many young women and men into this industry as possible, because we're going to need their intellect and their passion and commitment. Thanks, Stephen.
Thank you very much, Sir Jim. That was absolutely fantastic. There's so much there to absorb and digest, and now we're going to examine some of the ideas that you put forward there. So at this point, I'd like to bring in our panel. Karen, Vinny and Myrtle, please put your cameras on. I'm sure you've got some observations or questions or both to ask of Sir Jim. So why don't I come to Karen first of all, just your response to some of the things that you heard to Sir Jim, please.
Okay, so I mean, I think, you know, Jim taking the systems approach ties in very much to what we've been looking at in the Centre for Energy Policy, where, you know, we've worked out, you know, there's a number of principles here that we need to take account of. You know, first of all, we need to understand who really pays, noting that people don't just pay through their energy bills, and that carbon pricing doesn't give us all the answers. You know, we need to think about how and when do people pay, and how can we balance this with gains that we get. That's fundamental, particularly if we're going to build societal consensus, which is essential to actually realising this whole thing. We need to find, you know, different pathways that are going to allow us to grow and sustain our prosperity in an equitable way. You know, where can we trade off? Some things are going to inevitably bring us net costs. How do we trade off the gains to try and deliver outcomes that, again, you can build consensus around because they're equitable and they allow things to grow? We're going to need to find options and solutions that give us near-term economic returns. And this isn't one issue now, is actually enabling a green recovery from the COVID crisis, and thereby hopefully kind of convincing people that going to net zero doesn't mean to say you need to lose your economy and all your incomes. We need to ensure that we don't simply offshore. Now, this is the question that I think is a useful one to raise after Jim's talk, and to see what his thoughts are. You know, is that offshoring is that particularly post-industrialized countries have done a lot. You know, you major industries shut down and shift, so our emissions go down, but they've not gone down in the rest of the world, and that costs jobs and GDP at home. And I think my question to Jim would be, you know, would you agree that, I think when we're talking about systems language, it's been common in the past to think about cost optimization and finding the least cost solutions. If we take, you know, for example, renewables, you know, real challenge there, particularly because when we started renewables, we were trying to get going quick. So there's a temptation to find the least cost and the easiest way to do it. We imported an awful lot of our supply chains. Yeah. And now, again, we're growing renewables, but we're needing to find solutions quickly and get moving. Would you, one of the real risks here is that in trying to minimize costs, we're going to offshore quite a lot, and we're at risk of not realizing the opportunities to grow from this.
Yep, thanks for that, Karen. I'll come straight to that question. What I will say, that one of the, in this uncertain world, one of the things that we should start to rely on is an absolutely consistent narrative and commitment from government. As we saw what happened when, remember, when electricity market reform came in, how it stalled so much, and how the commitment that previous First Minister have made in Scotland to building that renewable industry didn't come off because of constraints. The regulatory system wasn't lined up with economic opportunity. Economic opportunity get damaged because of changing government priorities. We need that consistent, laudable and big vision commitment. So to your point about supply chain, I couldn't agree more with you. When it would be 10 years ago, when the Scottish Energy Advisory Board was first set up, we anticipated something like 27,000 jobs in Scotland that would come from that low carbon industry. And it was around wind energy, it was around carbon capture and storage, it was around grid, and a fraction of that came, probably somewhere around 20% or so. And that was a missed opportunity. So to your point, I think it's been recognised, that hard lesson, Karen. I'm just finishing chairing a piece of work that I was asked to take on by SOWEC, the Scottish Offshore Wind Energy Alliance or a consortium by Mr. Wheelhouse and Brian McFarlane and SSC, and it's to help identify and build opportunities for the supply chain. Now, where is it likely to land? Floating wind is a big opportunity. I won't go into detail, but there's a very large international turbine manufacturer that's about to land another very big investment in the UK. So things are starting to move towards the UK because there has to be projects, Karen. Yeah. There has to be a stable base for the policy makers. There has to be a welcome in terms of the fiscal arrangements that get them in there. But then there has to be that stickability of the jobs are then created, and we can do that all the better with a very solid supply chain. So we need to get the big players in, but we need to support that. And again, I'm loath to mention particular companies because if I mention some, I won't be mentioning others. But up around Nig and Moray and in Aberdeen and Dundee and in some parts of the islands around Scotland, there's a real opportunity to build. And then around that, there's infrastructure like grid controls, the whole aftermarket around operations and maintenance. And we need to keep as many of those jobs as proper. And you can only do that, Karen, by taking that systems perspective and tell the story as why is this important for society? We shouldn't be beating people over the head about climate change. They should be aware of it. And our younger generation particularly are, but we should be talking about the opportunities it brings in terms of new jobs, green jobs, stickability, the idea of creating a sustainable green set of industries. That's what people get excited. I much prefer to be encouraged to do something rather than being told to do something. And you can do that by getting that systems perspective and a very credible and ambitious narrative for Scotland and the UK.
Super, thanks, Karen. Thanks, Sir Jim, for that answer. Great answer and response. So I want to go to Myrtle now. Myrtle, bring you into the conversation. Myrtle, I'm sure you've got some commentary to add to this conversation.
Hey, yes, look, it was fantastic to hear and some really interesting things. And as an engineer, in fact, I was speaking to Vinny around systems thinking, not quite as big as you were thinking, but that if we were doing this as an engineering project, we'd have been looking at energy balances and useful work from wind turbines all the way to the customer consumption. So really good. I suppose the thing that I thought was very interesting, though, is you did talk about the global interconnected world, which is fabulous. And we do have COP26 coming up. And this issue about the winners and losers, I mean, what would you ideally like to be coming out of COP26 so that the current winners are just not winning more and the current losers are not just losing more?
Yeah, that's a fantastic question, Myrtle, and I'll try and surf the politics of this and stay in the engineering and the practicalities. I think that Paris was very important. There's no doubt about that, and the zeitgeist of folk that think about this around United Nations Sustainable Development Goals is fantastic. These are big pillars on which we build. What I would like to see is an alignment between government, regulation. I haven't said too much today, and your questions perhaps encourage me to go back to the investment community needs to be behind this as well. So what I'd like to see out of COP26, apart from profiling Scotland's wonderful distinctiveness, is that we get this convergence between policy, industrial power, innovation from universities and other places, and then the financial activities. So in many ways, I'm back to systems again, Myrtle, I'm sorry, but what I would like to see out of it over the next 5 to 10 years, because we need to have it in the next 5 or 10 years, is if we do the aggregate over the COP26 membership, the trillions of dollars that will have been committed into new, resilient, low carbon infrastructure that has created jobs, not only, as you suggested, in the big industrialized nations, but take that open, honest and progressive approach to bringing those growing into industrial nations countries and make sure our supply chains are interconnected as well as our physical systems. So again, I'm conscious I want to keep the response low, but let me take Malawi, for example, Myrtle. They have a massive requirement for probably about half a gigawatt to a gigawatt of power now. Now, out of goodwill, a lot of the big organisations that go in there try to replicate existing infrastructure, build a couple of big power stations, build a couple of transmission lines, and Lilongwe will get lots of electricity, but the villages won't. The entrepreneurial small towns won't. So in many ways, if we invert that and we say, let's bring innovation to that and use swarm electrification, and let's electrify the villages, the townships, allow them to interconnect, create jobs, release their entrepreneurial capacity. And can I tell you, in many ways, Myrtle, we'll learn more from building that sort of infrastructure and those developing economies than we will, in many ways, trying to deconstruct our own to try and decarbonise it.
Right, thanks.
Great stuff. Okay, Vinny, I'm going to bring you in to make your point, ask your question, and then we're going to move on to the audience questions. So Vinny, off you go.
Thank you. So it's always great to listen to you, Sir Jim. I think you provided some amazing insights, both from a technical and a social perspective. So thank you for that. So here's my observation. I think it feels like we've been talking about decarbonization forever, and now at the cusp of deploying net zero technologies at an unprecedented scale and pace, albeit hitting the ground running, but injected with steroids. That's how I feel. So from a fundamental R&D perspective, what are the opportunities and pitfalls universities and research and technology organizations like ourselves should be aware of, in your opinion?
Yeah, I think, let me give you an example to contextualize this, Vinny. So the UK government has made a commitment to get to 2.4% of GDP in R&D by 2027. Now, that's a big ticket number. It's all the more challenging given the pressures in the public purse now because of COVID. Nonetheless, BEIS UKRI, which OGTC knows very well, is still on the journey to £24 billion per annum in research and innovation. So what does that tell you? One, there's lots of existing technologies, and that I put that in one of my slides. So there's a big need for organizations such as OGTC to take these technologies which have come out of research labs, universities, innovative companies, and get them up to the high TRL levels. So there's a lot to be done that we mustn't forget about. I'll come back to the basic research because that is absolutely critical. You expect me to say that, so I won't disappoint you. But the high TRL activities are critical. And it's another place where UK tends not to capture the economic value. We need to get to high level, large scale demonstrators that proves then industrializes the technology for deployment. If we do that, we'll generate companies, we'll generate projects, we'll generate jobs, and that will feed back into the public coffers, which gives us the headroom. So back to your point, I think we need to also have a very well-funded basic research activity, and UKRI intend to do that. So we should let our researchers get under that discovery research activity. So it's a twin track and they're complementary. Let's exploit those technologies that already exist, get them up to high scale, the late stage demonstration and exploit them, but also release enough public funding as well as industrial support for the basic research and get that bandwidth open to discover the new technologies of the future. But there are enough technologies there just now to allow us to deploy lots in the next 10 years, and we need to get that done alongside the support for our basic research.
Yep. Thank you.
Super, thanks, Vinny. Conscious of time, I'd like to bring in some questioners from the audience. We're going to go first to David Wilkinson. David, if you can unmute and ask your question of the panel, please. And don't forget, it's the entire panel, not just Sir Jim. Anyone can answer. So please ask your question, David.
Hi, hello there. This is David Wilkinson from Aberdeen University.
Yeah, David.
Yeah, thanks for an excellent presentation, Jim. I enjoyed that. I was just wondering if you could comment on the competing publicity regarding hydrogen and electricity for domestic heating and domestic transport.
Yeah.
I've seen sort of false comparisons that have been put out on this, and it's looking a bit unfair at times. Have you any comment on that?
Yeah, I think you captured a great issue in any case, David. But particularly when media like to present things in a real, shall we say, boiled down way, it's normally they try to get some competing arguments. I.e., well, if it's hydrogen, it can't be electricity, and if it's electricity, it knocks out the opportunity for hydrogen. So, and you're right. I mean, I think that's where engineers, that's where organisations like the Royal Academy of Engineering, that's where organisations like OGTC, Aberdeen University have a duty for public information and have a duty to get evidence out there. So we go away from the opinion-led copy to evidence and data-led. So what I would say to you on hydrogen, the argument that I would make, and we're going to have to make, and I won't go into detail, but Scotland is currently evaluating some very significant inward investment opportunities in hydrogen, as well as how the oil and gas industry can segue into that hydrogen production. It's full of opportunity. Now, hydrogen arguably is going to be more important for decarbonising the industrial sector and not necessarily being used for fuel for vehicles. So if I come back up to my thesis originally, David, if we take that systems perspective, for me, that gives us the framework for making these high quality narratives and say, look, it's not any one vector here. It's a multiplicity of these things that feed into achieving that big vision, decarbonised energy system, whether it's for transport, industrial processes, or for heating. What I would say is we don't know yet what perfect looks like, but I will tell you, we'll never get there unless we start moving now. So that's why I would say these big demonstration projects, let's evaluate. If hydrogen is going to be better for heating than for industrial processes, then let's use it for that. But the infrastructure that needs to put in place could be a constraint. But I would think that some of these low regrets things I talked about, the electrification of transport is a key. The electrification for heating and cooling is a key. And let's get these building blocks in place, and then we can optimize. I'm an engineer, David, so the 80-20 rule works fine for me. If we try to get this, elusive perfect solution, we're never going to get there. So I would say, let's get started over the next 10 years. Let's get some big projects, get the data, and then we can evaluate. But just now, I agree with you. The public debate around hydrogen versus electricity is a distraction. Let's get the big projects in place, and let's get the data that informs our decisions.
Thanks,
Right,
David.
yeah, thank you. That sounds good.
Thanks, David.
Thank you.
Great question. I'm sorry, I'm going to have to move on. I've got a few other people queuing up. I'm going to bring Reza from Aberdeen University into the discussion. Reza, you've got a great question. I think actually Myrtle would probably be quite interested in answering this one. So Reza, please do go ahead and ask your question.
Very much. Can you hear me?
Yes, we can.
Yes, okay, thank you. Thank you, Jim, for your excellent presentation. I really enjoyed that. I'm excited, like everybody else, with regard to the renewable energy and all the changes that we are planning for future. But I have at the same time some concern. In other words, on one hand, we are excited by renewable energy sources, targets, plan, and regulations. But in my opinion, on the other hand, it seems that we are forgetting about the potential future negative impacts of renewable energy sources. My question here is simply, is that any discussion, thinking, or plans to deal with this potential environmental and social risk that we might have in future? Do not want, and you said that you're an engineer, we do not want to repeat the experience of oil and gas problems, potential problems that at the moment we are facing in terms of decommissioning. What about the renewable energy and this new movement in the society.
I might defer to Myrtle in the first instance, Stephen, then I can combine that.
Sure. Myrtle, any views?
Yeah, so thanks. We've been discussing this for a while now. We haven't really got a plan on the way forward, but my thoughts are this, that the energy is renewable, but the resources and the materials normally are not. And so we do have to make sure that what we're doing is sustainable. And I do note we mentioned that today. So the sustainability is super important because you know, when I was at university and we were doing our calculations, we used to talk about sinks. These are the very sinks now, which we're saying are not sinks, actually, they have an impact. And we have to have exactly that same approach when we are looking at doing things on a huge scale. I don't think it should stop us doing things on a huge scale now because there's bigger scale to come, but it means that we have to think about the life cycle more. We have to think about reuse. We have to think about making things more efficient so we don't use as many of them, so on and so forth. And, you know, and to some extent as well, this obviously is not just industry, it's a consumer. But, you know, even things like, you know, I was very glad that Sir Jim brought up nuclear, and things such as nuclear is definitely part of the future if you look forward. But there is this public perception about that, equally around climate change. And we're going to have a different discussion, I think, with the public and the awareness as to how we balance these things and how we balance overall sustainability. Yeah. Where we could run into another problem by running out of the very materials which we're using to progress our net zero ambitions. Sorry.
Yeah, Myrtle, a great point. Stephen, I can give a very quick response to Reza. I mean, Reza, I'll just take your point generally. I mean, what I will say is that this is why the students that you and David and I educate are key, because we should be, those that are engineers or designers or material scientists, have them fundamentally understand why sustainability is important in the design cycle, and that whole circular economy meets engineering design is key. But just a brief example, if we think about electrification, you think about the challenge for bringing ore out of the ground, whether it's copper or storage for cobalt or lithium. If we have to take a systems perspective, we now need to think about how do we make the mining industry sustainable? How do we decarbonize mining, and how do we do extraction in a way that doesn't overly damage the environment but creates local benefit? So it's systems within systems, Reza, but at least over the past 10 years, the penny is dropping, that we're understanding we have to take that systems perspective, and there is no magic bullet that it's just offshore wind or it's just marine or it's just energy efficiency. It's all of these things, and then when we try to achieve them, then we need to layer in that systems approach to delivery.
Super, thank you for that, Reza. I want to ask Imran Mohammed to ask his question. I'm conscious of time. We're almost out of time. I think this is quite a great question to finish on. And apologies to everyone else. We will get back to you with some form of answers to your questions, I'm sure. But Imran, can you please pose your question to the panel?
Yeah, sure. So Imran Mohammed from SSEN Transmission. So my kind of question to the panel is, what are your views on the importance of engaging with the general public on this journey towards net zero?
I'll let someone else start that, Stephen.
Yeah, I think it's a great. I mean, I'm thinking particularly on your point about the systems thinking view, because generally the narrative is based on binary type of arguments rather than systems thinking. So maybe Vinny, if you could kick off with that, please.
Yeah. Thanks for that. So I think, Imran, that's a great question, to be very frank. And I think what's been mentioned here is there has been a lack of engagement. And from a just transition perspective, I think we still need to engage the public over all these matters. And public's perception is key, I believe. And as Myrtle alluded, you know, whether it's the concept of nuclear or even renewables, I think we need to take the public into confidence. So I would strongly suggest, you know, to try to take the public into confidence, and also the Energy Trilemma that Sir Jim mentioned. I think that's something that we need to take and you know, use that towards policy making going forward. So that would be my take on it.
Jim?
And I would just add an advert for the Royal Academy of Engineering, Stephen, have a look at the Royal Academy of Engineering website, Imran. There's a programme called This is Engineering. The work of the Royal Academy has now have everyone recognised. We have a This is Engineering Day now every November, and that's the Academy can take a lot of the credit for that. But have a look at This is Engineering. The website has been hit almost 50 million times, predominantly by people aged 12 to their mid-20s, and in there the storytelling is by young people. Sadly, it means I need to recognise I am no longer a young person, in spite of what I can do on Zoom to improve my image. So the stories being told by young engineers like you, Imran, is critically important. Stimulate interest, get as many young women and men as more of a, I mean, remember, innovation comes better from a diverse and inclusive set of individuals. And the more inclusive and diverse we get going, the more stories we can tell, the greater innovation we can introduce. But let these young people in particular tell the stories. That's much more compelling, because they're going to be the solution that gets us out of the hole that my generation have by and large dug for them.
Thank you so much, Imran, for a great question to really end on. As usual, so many questions stacking up like planes over Heathrow. We don't have enough time to land them. We'll see what we can do to actually address some of those questions later on. But it just leaves time for me to say thank you to Sir Jim for a fantastic session today. Great presentation, great answers. Thank you to our wonderful panel for adding really great insight to and observations to Sir Jim's presentation, and to you, the audience, for taking part and asking such insightful questions. Please do follow us on LinkedIn, follow us on our website, look out for the next Insight60. We're going to be talking about an innovative energy island up in Shetland. All the kind of work that's been going on the Orion project should be fantastic and very, very enjoyable. Do join us for that. That will be in April. So great stuff. Thank you everyone for joining us, and we'll see you next time. Thank you.
Thank you very much. Bye-bye.